So in this lesson, we're going to talk about electrons and energy levels. All right, so I want you to take a look at this picture right here and this inquiry question. Are pairs more stable? Rowing can be hard work, especially if you are part of a racing team. The job is made easier because the rowers each pull on the water with a pair of oars. If you notice, each one has a pair. Okay. How do pairs make the boat more stable? That would be a question. Think about how because they have two oars, how does that make the boat more stable? And if we were to take away an oar from each one of these individuals, would it change the way the boat would react? Okay, so that's where we're starting with, is that question. Okay, so vocabulary, key vocabulary terms are these three: chemical bond, valence electrons, and electron dot diagram. Please write that information down in your science journal, and we will come across those definitions so that you can write those down also. Essential questions that we need to know by the end of the lesson. How is an electron's energy level related to its distance from the nucleus? That's question one. The other one, why do atoms gain, lose, or share electrons? Those two plus these vocabulary words, they all need to be written down in your science journal. Okay? You do not have to answer these questions yet, but by the end of the lesson you should be able to. Okay? Make sure that you write those terms down so that we can write the definitions when we come by them. All right? Now, you are picking one. Picking one of these three questions to write in your science journal and answer from this information. Okay? What do you think would happen to the boat if one of the members of the team lost an oar? So if you're looking here and only say this person right here lost this oar, what would happen to the team? What would happen to the boat? Okay, question two. How do you think the boat would move if each rower only had one oar? Okay, so now we're taking away one oar from each one of these four rowers. How do you think the boat would react? And question number three. If the rowers on this team had a total of one or two oars, could they beat a team whose members had all 8 oars? Why or why not? Okay, so you're answering one of these three questions in your science journal. You're writing the question and the answer, please, and we'll be talking about it in class.
The periodic table. Imagine trying to find a book in a library if all the books were unorganized. Books are organized in a library to help you easily find the information you need. The periodic table is like a library of information about all chemical elements. A copy of the periodic table is on the inside back cover of this book. The table has more than 100 blocks, one for each known element. Each block on the periodic table includes basic properties of each element, such as the element's state of matter at room temperature and its atomic number. The atomic number is the number of protons in each atom of the element. Each block also lists an element's atomic mass, or the average mass of all the different isotopes of that element. Periods and groups. You can learn about some properties of an element from its position on the periodic table. Elements are organized in periods, rows, and groups, columns. The periodic table lists elements in order of atomic number. The atomic number increases from left to right as you move across a period. Elements in each group have similar chemical properties and react with other elements in similar ways. In this lesson, you will read more about how an element's position on the periodic table can be used to predict its properties. Reading check. How is the periodic table organized?
Okay, you're going to need to recall that in prior lesson we had gone over the information about elements and what is in one of the blocks on the periodic table. Please review that information in your notes so that you can be fresh on that memory when we go through this information. Okay, so what I want to do now is provide you with, of course, the wonderful things that you love. Oops, let me move this. And that is your questions. You're going to pick one of the 3 questions listed. One of these 3 questions, you're going to write it in your science journal. You are going to answer the question. So what is the periodic table? The second one, what does each block on the periodic table list? And the third one, how is an atomic number different from atomic mass? You need to pick one of these 3 questions to answer, writing it in your science journal, writing the question and the answer in your science journal. Remember, if you need to, you pause the video, you write your information down, and you then play it and start the video again once you've gotten all the information.
Metals, nonmetals, and metalloids. The 3 main regions of elements on the periodic table are shown in Figure 1. Except for hydrogen, elements on the left side of the table are metals. Nonmetals are on the right side of the table. Metalloids form the narrow stair-step region between metals and nonmetals. Reading check. Where are metals, nonmetals, and metalloids on the periodic table?
Okay, so let's quickly take a look at this chart. You'll notice that the table or the key right here telling you which is which. The blue is metals, the green is metalloids, and the kind of yellowish, light yellowish or tan is nonmetals. Now, you'll notice that this one right here is left all by itself sitting with all those blues. Well, hydrogen, which is this right here, which is the very first element in the chart, is grouped with metals because when it is a solid form, and that happens when it's under extreme pressure, it takes on the properties of metal. So it's more like a metal when it's in a solid form. Okay, so notice where everything is located, usually located together except for this one, but the reason why is because under pressure as a solid, it performs more like a metal than it does a nonmetal or a metalloid. Okay? So why do you think that they arranged the chart in colors like this? Why do you think the chart was arranged in colors like this? Okay, there are 3 different colors plus these grays here. The reason why is because it's easier for you, me, and everyone else to see the difference in each one of those areas. So they arrange them together, okay? They arrange them together to make it easier to spot similar things. The periodic table also uses color to arrange the elements into groups. So certain groups, metals, metalloids, and nonmetals, can now be identified in this chart. If they weren't in any color at all, if they were all the same color, you would not be able to identify where one starts and the other one ends. Okay, so that's the reason why they use color in this chart. Okay, so now what I want to do is make the chart small, move my questions, and of course give you these questions to pick from. You're picking one of these 3. You're writing the question down as well as the answer in your science journal, please. Question number 1, what does the green color show on the periodic table? Question number 2, where are metals, metalloids, and nonmetals on the periodic table? Question 3, the suffix oid, O-I-D, means like. Why do you think the elements that are shaded green on the periodic table are called metalloids? So you're picking one of these 3 to answer, writing the question and the answer in your science journal.
Atoms bond. In nature, pure elements are rare. Instead, atoms of different elements chemically combine and form compounds. Compounds make up most of the matter around you, including living and non-living things. There are only about 115 elements, but these elements combine and form millions of compounds. Chemical bonds hold them together. A chemical bond is a force that holds two or more atoms together. Electron number and arrangement. Recall that atoms contain protons, neutrons, and electrons, as shown in Figure 2. Each proton has a positive charge. Each neutron has no charge, and each electron has a negative charge. The atomic number of an element is the number of protons in each atom of that element. In a neutral, uncharged atom, the number of protons equals the number of electrons. The exact position of electrons in an atom cannot be determined. This is because electrons are in constant motion around the nucleus. However, each electron is usually in a certain area of space around the nucleus. Some are in areas close to the nucleus, and some are in areas farther away.
Okay, so let's do some review vocabulary. When we talked about atoms bond, remember that when atoms come together or combine, they form a compound. And compounds make up most matter around us. Okay, compounds were something we talked about in a prior lesson. So I want you to make sure that you review those lessons so that you are fresh and ready to go with some of the information that's in this one. Remember, we talked in class that we would be building on what you already knew. So please refresh your memory. I know it's been a while since you've looked at this information, but please go back through your notes and refresh your memory about the information for compounds. Okay, so the next thing I want to do, I want to make this small, and bring this over, and also remind you that this right here was a vocab question or a vocab word and definition, so please make sure you're writing that word and its definition in your science journal. Again, as I say this, I'm going to tell you many, many times to do this, and I'm hoping you're following these instructions, and that is pausing the video, writing the word and its definition in your science journal, and then restarting that video where you left off. That way you have the information written down, and you can move on smoothly, understanding and having that all ready for you. Okay, so the next thing I want you to do is pick one. Pick one of these three. Okay? You're going to write the question and you're going to write the answer. What do atoms create when they combine? Question number 2, what is a chemical bond? Or question number 3, why do you think compounds make up most of the matter around us? Okay, so you're picking one of these three questions. You are writing the question down and answering the question in your science journal.
Electrons and energy. Different electrons in an atom have different amounts of energy. An electron moves around the nucleus at a distance that corresponds to its amount of energy. Areas of space in which electrons move around the nucleus are called energy levels. Electrons closest to the nucleus have the least amount of energy. They are in the lowest energy level. Electrons farthest from the nucleus have the greatest amount of energy. They are in the highest energy level. The energy levels of an atom are shown in Figure 3. Notice that only 2 electrons can be in the lowest energy level. The second energy level can hold up to 8. Check. How is an electron's energy related to its position in an atom? Electrons and bonding. Imagine 2 magnets. The closer they are to each other, the stronger the attraction of their opposite ends. Negatively charged electrons have a similar attraction to the positively charged nucleus of an atom. The electrons in energy levels closest to the nucleus of the same atom have a strong attraction to that nucleus. However, electrons farther from that nucleus are weakly attracted to it. They can easily be attracted to the nucleus of other atoms. This attraction between the positive nucleus of one atom and the negative electrons of another atom is what creates a chemical bond.
Okay, as I was showing while they were reading through the information, this, of course, is your nucleus. Okay? Positively charged nucleus attracts the negatively charged electrons. Electrons are negative. Remember, you have positive protons, you have neutral. Okay, so you have a couple of three different things working here for you. The neutrons are neutral, protons are positive, electrons are negative. So, if you look at the blue right here, the darker of the blues, you'll notice that there's a little circle. Okay, you have two dots on that circle. The information, electrons in the lowest energy level, which would be the closest, the energy level that's closest in the nucleus, the electrons in that energy level, which is closest to the nucleus, are strongly attracted to it. They're strongly attracted to the nucleus. Similar to the way a paperclip is strongly attracted to a nearby magnet. Okay, the lowest energy level can hold only 2 electrons. So if you take a look, the closer the magnet is to the paperclip, the more attraction there is. Same way with this outer energy level here, okay? This is a fluorine atom, by the way, a fluorine atom. So, the outer energy level, okay, if you notice, as it says here, electrons in energy levels farther from the nucleus have a weak attraction to the nucleus, similar to the way a paperclip is weakly attracted to the magnet furthest away. So the further you pull the magnet away, the weaker the attraction is on the paperclip. The outermost electrons are involved in chemical bonding. That would be these out here. These are more attracted to a nucleus that might be closer to them. Remember, the nucleus is negatively charged. I'm sorry, let me try that again. The nucleus is positively charged, the electrons are negatively charged. So these electrons in the outer band here, or the outer energy level, are more susceptible to be pulled towards another nucleus. All right, so I want you to remember that the electrons, which are these units here, these are electrons, they move around the nucleus of an atom in a cloud. Okay, remember it's called the electron cloud. Okay, so next, make that small, bring this up, making it large. You are to write down both questions, this one and this one, in your science journal and answer them, please. Okay, so the first one is, and make sure you write it because it is one of our key concept checks, how is an electron's energy related to its position in an atom? That's question 1. Question number 2, why are electrons farther away from the nucleus able to interact with other atoms? So question 1, question 2, you write them both down. Write both of them down, okay, and answer both of them, please.
Valence electrons. You have read that electrons farthest from their nucleus are easily attracted to the nuclei of nearby atoms. These outermost electrons are the only electrons involved in chemical bonding. Even atoms that have only a few electrons, such as hydrogen or lithium, can form chemical bonds. This is because these electrons are still the outermost electrons and are exposed to the nuclei of other atoms. A valence electron is an outermost electron of an atom that participates in chemical bonding. Valence electrons have the most energy of all electrons in an atom. The number of valence electrons in each atom of an element can help determine the type and the number of bonds it can form. How do you know how many valence electrons an atom has? The periodic table can tell you. Except for helium, elements in certain groups have the same number of valence electrons. Figure 4 illustrates how to use the periodic table to determine the number of valence electrons in the atoms of groups 1, 2, and 13 through 18. Determining the number of valence electrons for elements in groups 3 through 12 is more complicated. You will learn about these groups in later chemistry courses. The total number of electrons in a neutral atom is the same as the atomic number. Groups 1, 2, 13 through 18. The number of valence electrons in an atom equals the ones digit of the group number. Helium, He, is an exception to the rule. Atoms of helium have 2 valence electrons. Groups 3 through 12. The number of valence electrons varies.
Okay, so valence electrons. If you take a look at the diagram that's right in front of you, and I'm going to make this a tad bit larger, maybe take off some of the top there. There we go. If you take a look at the diagram, you'll see numbers at the top of each one of these columns. Okay? Those numbers represent the group on the periodic table. So group is across the top, and groups are in columns. Okay? The number that's beside on this end, 1, 2, 3, these represent the rows. Okay? Rows. Okay? So what I want you to make sure you know is that the numbers at the top that I was pointing out are the number of valence electrons that are there, except when we talk about the numbers that are in the teens, when you take a look at this one, the valence electron is the 3. Notice how many dots are in the outside ring. That's 3. 1, 2, 3. Also notice the one underneath of it. 1, 2, 3. Okay? Notice in the next column or group, it is a 4. Of the 14, it's in the single digit or the ones column. Okay, so there are 4 valence electrons in everything in that column. There are 5 in this one, if you notice. 1, 2, 3, 4, 5. There are 5 in this one, 6 in this one, 7 in this one, 8 in this one, except for this one right here, which is helium. It is the only exception to this rule. Okay, so now you know what the valence electrons are by looking at the table. All right, valence electrons was one of our definitions, so let's go ahead and write that definition in your science journal, please. Valence electron is an outermost electron of an atom that participates in chemical bonding. So it's the atoms that are in the outside energy level. Okay, you can go ahead and pause that if you would like and write that down. Alright, so the next thing we're going to do is we're going to look at the questions that I want you to be writing down in your science journal. That would be these. And this time you get to pick one of the three questions that are here, please. Writing it in your science journal and answering it, please. What kind of electron is free to participate in chemical bonding? The question number 2, why is it useful to know the number of valence electrons in the atom? And number 3, which electron configuration do the elements in group 1 share? Okay, so you're picking one of those 3, you're writing the question in your science journal and answering it.
Electron dot diagrams. In 1916, an American chemist named Gilbert Lewis developed a method to show an element's valence electrons. He developed the electron dot diagram, a model that represents valence electrons in an atom as dots around the element's chemical symbol. Electron dot diagrams can help you predict how an atom will bond with other atoms. Dots representing valence electrons are placed one by one on each side of an element's chemical symbol until all the dots are used. Some dots will be paired up, others will not. the number of unpaired dots is often the number of bonds an atom can form. The steps for writing dot diagrams are shown in Figure 5. Reading check. Why are electron dot diagrams useful? Recall that each element in a group has the same number of valence electrons. As a result, every element in a group has the same number of dots in its electron dot diagram. Notice in Figure 5 that an argon atom, Ar, has 8 valence electrons, or 4 pairs of dots, in the diagram. There are no unpaired dots. Atoms with 8 valence electrons do not easily react with other atoms. They are chemically stable. Atoms that have between 1 and 7 valence electrons are reactive, or chemically unstable. These atoms easily bond with other atoms and form chemically stable compounds. Atoms of hydrogen and helium have only one energy level. These atoms are chemically stable with 2 valence electrons.
So as you look at this diagram, I want you to make sure that you see that each symbol has 4 sides. Okay? Each symbol, that would be these here, are the symbols. They have 4 sides. They have a left side, a right side, an up, and a down. Okay? So they have 4 sides. So you're looking at these symbols as 4 sides. You then identify the number of valence electrons, which is the step that's listed number 2. Okay? Valence electrons, that would be the number of electrons that's in the outer energy level, the energy level that's furthest from the nucleus. So let's look at beryllium. Beryllium, when we identify it, has 2 valence electrons, and we know this because when we took a look at the periodic table, the group number across the top that beryllium was in was a number 2. It was in group 2. So beryllium has 2 valence electrons. When you do the valence electrons, you want to make sure that you place a dot at a time on each side of the symbol. So you're starting with the top, okay? Top, right, bottom, left. Okay, top, right, bottom, left. But in this case, we don't have anything for the bottom and the left side. Only 2 valence electrons are there. So you use the top and you use the right, just like what's on the picture. When you take a look at carbon, which is here, right there, you identify the group number. Carbon's group number was 14. However, are we looking at 14 valence electrons? The answer would be no, because you're looking at the individual or the single side, which would be the 4. The right side number in that group of pairing is the number you're looking for your valence electrons. So in this case, valence electrons is 4. So your symbol is there. We're going to start putting the 4 around the symbol. So you have one on the top, one on the right, one on the bottom, one on the left. Now, it gets a little more confusing when we talk about more than 4. So, nitrogen. Nitrogen is in group number 15 on the periodic table. So we're looking at the 5. Okay? 5 valence electrons. Okay? So we start putting our dots. One on the top, one on the right, one on the bottom, one on the left, but we have one left over, so we're going to put the next dot at the top again. Okay? The next dot goes at the top. So that gives us 5 valence electrons and 5 dots around the symbol. Let's try argon. Argon is the next one. Okay, you're looking at 8 valence electrons. I apologize with the valence. I was told that's how it was pronounced, and now the book is pronouncing it differently. So, valence electrons, because we are in group number 18, we're looking at the right-hand number, which was 8, which tells us our valence electrons. And now we are going to put those around the symbol just like is right here. Okay, you go around once, and this time because you have 4 left over, you go around a second time. So you have 2 on top, 2 on the right, 2 on the bottom, 2 on the left. Okay, so I hope that explains that diagram a little bit. Alright, next we need to make sure you have your definition. Definition of electron dot diagram. Please write that definition with the vocab word in your science journal. We will be having a vocab quiz over that information. Okay, next. You're picking 2. Picking 2 questions to answer out of these 4. What do the dots on the electron dot diagram represent? Question 2. Why are electron dot diagrams useful? Question number 3. Look at the chart in figure 4, which was the one that we just looked at. Would an electron dot diagram for oxygen have the same number of dots as a diagram for sulfur? Why or why not? Okay, that was number 3. The last one. How are unstable atoms different from stable atoms? Okay, 2 of those questions, 2 of the 4 please, written down in your science journal.
Noble gases. The elements in group 18 are called noble gases. With the exception of helium, noble gases have 8 valence electrons and are chemically stable. Chemically stable atoms do not easily react or form bonds with other atoms. The electron structures of 2 noble gases, neon and helium, are shown in figure 6. Notice that all dots are paired in the dot diagrams of these atoms. Stable and unstable atoms. Atoms with unpaired dots in their electron dot diagrams are reactive or chemically unstable. For example, nitrogen, shown in figure 6, has 3 unpaired dots in its electron dot diagram, and it is reactive. Nitrogen, like many other atoms, becomes more stable by forming chemical bonds with other atoms. When an atom forms a bond, it gains, loses, or shares valence electrons with other atoms. By forming bonds, atoms become more chemically stable. Recall that atoms are most stable with 8 valence electrons. Therefore, atoms with less than 8 valence electrons form chemical bonds and become stable. In lessons 2 and 3, you will read which atoms gain, lose, or share electrons when forming stable compounds.
Okay, so the reading talked about pairings of dots on the dot diagram. Notice that each side is equal. There isn't a side that doesn't have an equal number of valence electrons. This one also. I know this looks weird because you would have thought in the directions that we were talking about that if it had 2, that you would have 1 at the top and 1 on the right. However, because an atom's lowest energy level can only hold 2, and that's all it has is 2, the dots are paired together just like this to make it a chemically stable product. However, this one here on the end, nitrogen, you'll notice is not stable. It has unpaired electrons on the right, bottom, and left when there are 2 paired at the top. So the ones on the top are chemically paired, but the other 3 need another one. So the way that atoms become stable or chemically stable is they gain or they lose or they share valence electrons. That's the way that they become chemically stable. All right, so in the picture here, you'll notice I have 5 questions. 1, 2, 3, 4, 5. You are picking 3 questions to answer, but one of them has to be the key concept check question. So writing the information in your science journal, you are going to pick 3 of the 5 to write down. So the first one over here, of course, you're going to write down, why do atoms gain, lose, or share electrons? Please write that in your science journal and answer that question. Now, the other 4, you can pick 2 more. Okay, 2 of the 4. So, what group of elements is located in column 18? This one. How does helium differ from the elements in its group? And this one here. Do the elements in group 18 have stable or unstable atoms? And it asks you to explain. Okay, and the last one you get to pick from is, how can unstable atoms become stable? So again, with the directions, you are definitely writing this one down and answering that question in your science journal, and you are picking 2 of these 4 to write down and answer. Okay, we've now come to the end of this lesson. So you're going to be writing down questions and answers. Actually, you're only going to be answering this one, and this one. You're going to be answering those in the science journal, but you're going to be writing the questions with only one answer on this one. Okay? This one, just answer, and this one you're going to draw the chart and answer. Okay? So just answering the first 3, answering number 4, writing the question and just the correct answer for number 5. You are just answering number 6, just answering 7, and drawing the chart for number 8. Okay? I hope you learned something from this lesson. We will be talking about the questions that you may have in class. Have a great day.